Mile marker 3, linear inequalities. First off, we've got to recall what exactly is the inequality symbol. They are less than or equal to, greater than or equal to. The solution of an inequality is a value that makes the inequality true. Let's look at x is less than 5. That means any number less than 5 makes the inequality true, which includes 4, 3, 2, 1, 0, -1, -2, and all the fractions, decimals that go before it. Since we cannot list all possibilities, we write solutions in different forms, such as set notation, graph, and interval notation. Looking again at the inequality x is less than 5, let's look exactly at set notation. Now, if you were looking at that, how would you say it? Well, math is its own language, so let's see what it really means. The bracket part means the set of. Next, we read it as all x values. Such that is that straight bar. X is less than 5. Now this is more of the formal way to write it, but that is how you say it. Each symbol has its very own meaning. Next we're going to look at the graph. Now graph makes you think of the number line. And so we know that something is happening at 5. 5 is the defining point on the graph. But we don't know if the values, what values are less than 5. Well, less than means smaller than. So we said that 4 is less than 5, 0 is less than 5. So all these values to the left of 5 would make this inequality true. So we shade it. We draw an arrow and we shade that whole half of the number line. Now we have the use of new symbols. If we want to include the value 5 in our solution, we would use brackets. If we do not include the 5, we need to use parentheses. And so if we go back and we look at our inequality, that less than means we do not include it. So we are going to have to use parentheses. Now, you want the parentheses facing the direction it's shaded, which means we're going to use the closed parentheses. So we're going to put a parentheses on the number line right there, facing our shaded direction, and that is our graph of the solution set. Again, graphing is the visual representation. Next, we're going to talk about interval notation. Interval notation is made up of 4 different parts, and it kind of takes on this form. Now, the boxes on the end, the blue and the green, are either going to be parentheses or brackets, and the values in the middle determine the smallest and the largest values of the solution set. So we need to decide how we read this. When it's talking about the left, the blue box, it means how far left does our graph go. And notice our graph goes for forever and ever. It means I need to know the smallest value. And the smallest value we ever get to is infinity. Now, does anybody know exactly where negative infinity ends? The answer is no. So we put a negative infinity in the box that is the smallest value. Negative infinity, infinity looks like a sideways 8. But because we do not know exactly where infinity ends, we cannot use a bracket. Instead, we must use a parenthesis. So it's going to be a parenthesis. Negative infinity, because it's the furthest left our graph can go. And then as we follow the graph to the right, so I'm following it to the right, furthest to the right that I'm shading, and it stops right here at what number? It appears to stop at 5. And so at 5, that is the furthest right our graph goes. Now we have to decide, at 5, do we include 5 or do we not? Well, remember, we had a big parenthesis facing that way, so that parenthesis helps to remind us that it will be a parenthesis in our interval notation. So, to see your interval notation, it will look like this. It'll be parenthesis, negative infinity, negative infinity, comma, 5, parenthesis. That would be your interval notation. It is made up of those 4 parts, but that's what the final result would look like. And again, interval notation is the most common. Alright, our first example, solve, graph, then write an interval notation. So we are going to solve, although these are not equations, they're inequalities, they still have 2 sides to the problem, and we're still on a mission to get x by itself. So to get x by itself, we would need to add 5 to both sides. And when you do that, that gives you that x is greater than or equal to -2. So we have solved it, but now we need to graph it, which means we need a number line. And we knew that something was happening at -2. This is our defining point right here at -2. We want to shade the numbers that make this a true statement. So I'm going to do a test point. I'm going to choose the number 0. Is it true that 0 is greater than or equal to -2? Is that true that 0 is greater than or equal to -2? And because it's true, that means that's the half of the number line I want to shade. Those are the numbers that will make this a true statement. So I shade all those numbers to the right. And now I have to decide if I'm going to use a bracket or a parenthesis. So I look back at my inequality, and it says greater than or equal to. And our post-it means I am going to include that -2, which means I am going to use what? A bracket. So on our number line, at -2, I want a bracket facing the direction that I shaded. And so there is my graph. Once you have your graph, now you need to write your interval notation. Interval notation starts from left to right. So as we're looking at the graph, the leftmost region is right here. That's the smallest value we ever get to. And that value happens to be what? -2. And at -2 we used what symbol? A bracket. And then our graph continues to the right until how far? Well, it has an arrow meaning it continues for forever and ever, which means it must be infinity. And nobody knows where infinity ends. There's no exact value, so we must use a parenthesis. And that would be your interval notation. Example B, now we're going to solve this inequality. Again, inequalities still divide the problem into a left side and a right side. We notice we have x's on both sides of the inequality, so they need to be on the same side. So I'm going to subtract 4x on both sides. And 4x minus 4x does cancel, leaving me with -11. And then 5x minus 4x gives you x, and x minus 7 is less than -11. Still need to get x by itself, so we need to add 7 to both sides. And when we do that, we find x is less than -4. And now you have solved it. Once you've solved it, now we need to graph it. Now with the number line, you do need to have it labeled. So here's, call that 0, -1, -2, -3, -4. 1, 2, 3, 4. So I've got it labeled. And we know that something is happening at this point. Something's happening right here at -4. We just need to decide what half of the number line would make it true. So we can choose any number we want. We think it's going to be the numbers to the left. Let's try a number to the left. Let's try -6. Is it true that -6 is less than or smaller than -4? And that's true, which means that's the half of the number line we want to shade. We shade the left side of the number line. And then now we must decide the symbol. Because it is less than, that means it does not include. And if it does not include, then it means we must use what? Parentheses. So on the number line, we have a parenthesis facing the area that we shaded. Now that we have the graph, now we need to do interval notation. Interval notation is always going to be from left to right. So the furthest left that we ever go, because we have an arrow, would give us -infinity. And nobody knows where -infinity ends, so we cannot use a bracket, we must use parentheses. And then as we travel to the right along the number line, the furthest right we can go is what? -4. And we notice on our number line, our graph, we did not use a bracket, we used a parenthesis. And that would be your interval notation. Here's your try it problem. Alright, let's see how you did. 2x and 4 minus x. Subtract 24 on both sides. X is less than -9. And if something is happening at -9, defining point, values that are less than, -18 is less than, so I shade to the left. Because of the inequality, it will be a parenthesis. And so interval notation should be -infinity to -9 parenthesis. How did you do? Now, do you remember what we must be careful of if we multiply or divide by a number? Again, this is in regards to inequalities. The rule states when multiplying or dividing by a negative number in inequalities, we must reverse or flip the inequality symbol. Make note of that. Alright, so again, we are on a mission to solve for x, so we do need to do what? We need to divide by -4. But notice, what kind of number is that? Because it's negative, we just said if it's negative, it means we need to flip. It means it's going to reverse. And so my inequality is now going to be x is less than or equal to -6. For my solution, I'm now ready to graph. Alright, so I've got a glimpse of the number line. Something is happening right here at -6. I want values that are less than or smaller, and that would be values to the left. So I shade my number line to the left. And then looking at the inequality, because it's less than or equal to, means it will be a bracket. And so my interval notation for this particular problem, starting from the left, would be parentheses, negative infinity, comma, -6, bracket. That's my interval notation for this particular problem. Now for problem B, again, we still need to solve for x, which means we are going to divide both sides by 8. Now notice 8 is positive, so there's nothing to be concerned about. And so we leave the inequality alone, and the answer is x is less than 4. And again, no flipping because 8 was positive. Now we need to graph it. I'm going to label it. And we know something happens at 4, that's the defining point, so something happens right here at 4. And we want to choose the values that are less than 4. And so I choose a value such as 0. Is it true that 0 is less than 4, or 0 is smaller than 4? That's true. So I'm going to shade to the left. And then I need to decide, because it's less than, that means it does not include 4. So it will be a parenthesis, which means I'm now ready to do interval notation. Starting from the left, it'll be negative infinity with a parenthesis to 4 with a parenthesis. Example 3, same directions. We're still on a mission to solve for x. Go ahead, draw your line so you see your two sides. First thing we need to do, we need to subtract 11 on both sides. Which gives us negative 3x less than or equal to negative 24. Excuse me. Now to undo the multiplication, we are going to do what? Divide both sides by negative 3. Warning, warning, what kind of number is that? Negative, which means this inequality needs to do what? Flip. It changes direction, so don't fall for that. Alright, negative 3x divided by negative 3 now gives you a positive x. Negative 24 divided by negative 3 does give you a positive 8. Now that you have your solution, you're ready to graph this. Alright, once you have a sampling on the number line, let's find out what this looks like. So we know 8 is where something's happening. We need the correct half of the number line. So what numbers are greater than or equal to 8? And if you're not sure, pick a point, which is 10. Is it true that 10 is greater than or equal to 8? Is that true? And since it is, that's the half of the number line we want. So we shade to the right of 8. And then we look back at the inequality. Because it's greater than or equal to, we are going to use a bracket at 8. And so now that we see the number line, interval notation, we work our way from left to right. It starts at 8, where we have a bracket, continues to the right to infinity, to forever and ever, where we use a parentheses. Alright, example B. Again, drawing my line so I see my two sides. Now this has more steps. We want to focus one side at a time. On the left side, you notice that we've got the distributive property, so we do want to take care of that. 3 times x is 3x. 3 times 5 is 15. And we still have that minus 1. Now on the left side, still, can we simplify? And notice we do have like terms. So we do want to combine that. 15 minus 1 is 14. There's nothing else we can do to the left side. Now turn your attention to the right side. And you notice that you can distribute. 5 times x is 5x. 5 times negative 1 is negative 5. And we still have plus 7. Again, we want to combine any like terms if possible. And you notice you have 5x minus 5 plus 7. The constants, negative 5 plus 7, combined to give you 2. Alright, we've simplified each side individually. Now let's look at the problem as a whole. Notice we have x's on the left and on the right. They need to be on the same side. I'm going to bring my x's to the right side since 3x is smaller. So to do that, I need to subtract 3x. Excuse me. I'm going to subtract 3x on both sides. And so the 3x minus 3x goes away, leaving me just 14 on the left side. And 5x minus 3x gives me 2x plus 2 on the right side. So I've gathered my x's, but now I want to get rid of any plain numbers, such as that plus 2. So to get rid of adding 2, I must subtract 2 from both sides. And I'm being fair because I've done it to the left side and the right side. The 2's cancel, giving me a 2x. And on the left side, 14 minus 2 is 12. We're almost there. The last thing that needs to take place is we do need to divide both sides by 2. And because 2 was positive, there's no reason to flip the inequality sign. And we're left with 12 divided by 2, which we know is 6. So there's our solution. Now we're ready to graph. Alright, so 6 is our defining point. We know something's happening right here at 6. We want to choose values that make the statement true. So let's try a number. Let's try 8. Is it true that 6 is bigger than or greater than 8? Is that true that 6 is bigger than 8? No, that's not. Which means we do not want to shade the right half. We need to shade the left half of the number line. So shading the left. Now we have to look back at the inequality. It is 6 greater than or equal to. Equal to means we do include, so we'll use a bracket. Now that we have the graph, we're ready for interval notation. Starting from the left, we have negative infinity, where we use a parenthesis. And as we travel to the right, we make it to 6, where we have a bracket. There's your interval notation. Here's your try it. Pause the video. Alright, let's see how you Sorry about that. X is greater than or equal to 1. Something happens at minus the defining point, greater than or equal to, will be to the right, and it does include 1.